Okay, this is Divakar Patil, and I'm gonna teach you the fourth unit of your subject 103 Modern Pharmaceutics. Okay, so the name of the unit is compression and compaction. Okay, so here are some definitions of this particular topic. First is compression. Compression means a reduce in the bulk volume of the material as a result of removal of gases phase by applied pressure. Okay, so basically in compression we used to reduce the bulk volume of the particular material, particular powder. Okay, particular powder by removing the gases. Okay, we reduce the surface area, or whatever we can say, the original volume of material. In short, we used to compress that specific material. Okay, suppose I have something in my hand like powder or anything, and by applying some pressure by other hand on that powder, I can reduce the pressure, sorry, reduce the bulk volume of the material. Okay, that is the compaction. मतलब कोई भी चीज को compress करना. ओके, कोई भी चीज को compress करना. ओके, उसके ओरिजिनल वॉल्यूम से उसका वॉल्यूम कम करना. ओके, सपोज मेरे पास कोई पॉलीथीन की बैग है. ओके, कैरी बैग है. ओके, उसके अंदर एयर है. तो मैं क्या करूँगा, उसको अगर बाहर से दबाया, बाहर से प्रेशराइज किया, दोनों हाथों में उसको पॉलीथीन को दबाया, तो क्या हो जाएगा, उसके अंदर की जो हवा रहेगी, एयर रहेगी, वो बाहर निकल जाएगी. सो दैट इज द कॉम्प्रेक्शन. ओके, जस्ट लाइक लड्डू पता होगा तुम लोगों को बूंदी का. ओके, तो वो कैसे बनाते हैं, हाथों में, दोनों हाथों में कंप्रेस करके बनाते हैं ना. कंप्रेस करेंगे, उसको रोल करेंगे, तब वो गोल बनेगा. उसके अंदर जो एयर रहेगा. ओके, उसके जो पार्टिकल्स रहेंगे लड्डू के, उसके अंदर जो एयर्स रहेगा, उसके अंदर उसको कंप्रेस करके, या फिर उसका रिमूवल होगा बाय कॉम्प्रेक्शन. और इस तरह से क्या बनेगा, वो जो लड्डू रहेगा, कोई भी स्पेसिफिक बूंदी का या कोई भी लड्डू रहेगा, तो वो बनेगा. ओके, दिस इज कॉम्प्रेशन. ओके, next is consolidation. Consolidation is an increase in the mechanical strength of material resulting from the particle-particle interaction. मतलब क्या कि अ, जो स्पेसिफिक कोई मटेरियल रहेगा. ओके, मटेरियल रहेगा, तो वो उसके ऊपर मैकेनिकल स्ट्रेंथ अप्लाई करके उसका पार्टिकल पार्टिकल इंटरेक्शन बढ़ाना, या फिर पार्टिकल पार्टिकल इंटरेक्शन बढ़ा के उसका मैकेनिकल स्ट्रेंथ इंक्रीज करना. ओके, सपोज मेरे पास कोई मटेरियल है. सपोज मैं लड्डू बना रहा हूँ. ओके, तो क्या रहेगा कि उसका जो रॉ मटेरियल रहेगा स्पेसिफिक लड्डू का, तो उसके ऊपर अगर मैं मैकेनिकल स्ट्रेंथ बढ़ाऊंगा. ओके, या फिर उसके ऊपर अगर मैं प्रेशर अप्लाई करूंगा, तो उससे क्या होगा, वो चिपक जाएंगे, उसके जो पार्टिकल्स रहेंगे छोटे छोटे, बूंदी के जो पार्टिकल्स रहेंगे, वो छोटे छोटे पार्टिकल्स चिपक जाएंगे. तो उससे क्या होगा कि उसका मैकेनिकल स्ट्रेंथ बढ़ेगा, या फिर जो पार्टिकल पार्टिकल इंटरेक्शन रहेगा वो बढ़ जाएगा. तो इससे क्या होगा, उस स्पेसिफिक जो मटेरियल रहेगा, जो लड्डू रहेगा, उसका क्या होगा कि मैकेनिकल स्ट्रेंथ बढ़ जाएगा, वो टूटेगा नहीं जल्दी. ओके, तो वैसे ही हम टैबलेट का भी करते हैं. कोई भी स्पेसिफिक टैबलेट रही या फिर पाउडर रही, उसको क्या करेंगे हम, पंच में अगर डाला टैबलेट पंचिंग मशीन में, तो उसको उसके ऊपर एक मैकेनिकल स्ट्रेंथ या फिर एक प्रेशर अप्लाई होता है. उसकी वजह से क्या होता है, उसका पार्टिकल पार्टिकल इंटरेक्शन बढ़ता है, वो पार्टिकल्स चिपक जाते हैं पाउडर के, तो उससे उसका मैकेनिकल स्ट्रेंथ बढ़ेगा, तो इससे हार्डनेस इंक्रीज होगा टैबलेट का. Okay, so next is compaction. Compaction of a powder is a general term used to describe the situation in which these material are subjected to the some level of mechanical force. Okay, compaction मतलब compact करना. Okay, जिसमें क्या होगा, कोई भी जो मटेरियल रहेगा, उसके ऊपर हम क्या करेंगे, प्रेशर अप्लाई करेंगे. ओके, एक ऐसी सिचुएशन किसी भी पाउडर की या फिर किसी भी मटेरियल की जिसमें हम उस स्पेसिफिक मटेरियल पे क्या करेंगे कि प्रेशर अप्लाई कर देंगे। ओके, मैकेनिकल फोर्स अप्लाई करेंगे। ओके, द फिजिक्स ऑफ द कॉम्पैक्शन may be simply stated as the compression and the consolidation of two phases, okay, such as solid phase or gas phase। ओके, तो इसमें क्या होगा कि मतलब क्या कि कॉम्प्रेक्शन और कॉम्पैक्शन क्या है कि दो कोई भी फेज रहेगी ना, गैस और सॉलिड, ओके, उसके ऊपर फोर्स अप्लाई करना, कॉम्पैक्शन। अभी सपोज पाउडर है मेरे पास, ओके, तो सिर्फ पाउडर तो नहीं रहेगी, उसके अंदर कोई ना कोई इंटर पार्टिकुलर स्पेस रहेगी, वॉइड स्पेस रहेगी, तो उसमें क्या होगा, गैस भी होगा। तो ओके, ये तो पूरा सिस्टम हो गया गैस, तो उसमें क्या हो गया कि दो फेज आ गई, गैस फेज भी आ गई और दूसरा आ गया कि सॉलिड फेज आ गई। ओके, तो इससे क्या होगा कि इसमें स्पेसिफिक जो दो फेजेस है उसके ऊपर प्रेशर अप्लाई होगा। ओके, सो दिस इज कॉम्पैक्शन। देन नेक्स्ट इज, okay, so next one is derived property of powder and or granules. Some derived property which help in quantification of important variables are, okay, means these are the properties of the powder which help in the checking how the powder is, how the tablet will be formed. Okay, these are the supportive properties or the main properties which help to determine that how the quantity quality of powder will be, okay, or how the uh, quality of the formulated tablet will be. Okay, in this first is volume, second is density, porosity and flow properties. Okay, first is volume. Measurement of volume of a powder is not easy as the measurement of mass of powder. Okay, because in powder there will be inter or intraparticular voids. Okay, hence three type of volume can be considered for the powdered mass. Okay, means just as like we measure the mass of the powder, okay, measuring the volume is not easy just as mass of the powder. Okay, because volume is a specific thing, mass is for the overall material or the overall what we say that what kind of material we have. Okay, so in volume there are three types of volume, okay, which are used to or which are considered for the powdered mass. Okay, first is true volume, second is granular volume and third is a bulk volume. Okay, then we'll see these before this we'll see the what is mass and volume interrelationship. Okay, so we have seen the powders. Okay, okay, some are coarse, some are uh, what we can say crystalline. Okay, some powders are amorphous. Okay, this kind of powder we have seen. Okay, this powder may have or may not have, but generally they have the voids in between them, okay, which occupies the air or which doesn't contain anything in that, means generally they have air inside them. Okay, so there are three types of voids. Okay, three types of voids present in the particular uh, particular powder or any material. In this first is open interparticulate voids. Okay, open interparticulate voids means interparticulate voids. See in this diagram this thing. Okay, open interparticulate voids. These are present in open to the sorry, open particulate void, particulate void are this kind of voids which are present which are present between the external environment and the powder. Okay, powder particles, or the particles which are solid particles which are present at the corners, or at the surface of the material, or that powder, bulk powder. Okay, means these are in contact with environment, these particles or these voids are in contact with the environment. Okay, these particles create these voids. Okay, that's why they are called as open interparticulate voids. Okay, because they are in contact with the external environment. Second one is closed interparticulate void. Okay, closed interparticulate voids are present inside the single particle. Okay, some particle may have the void space inside them, just like this void space inside them. Okay, so void space inside them. So what happens, uh, in these voids air can be entrapped. Okay, okay, and because these are inside the single particles, hence are called as closed interparticulate voids. Okay, the next is the interparticulate particulate void. Okay, what we have seen, open and closed interparticulate void and interparticulate void. Okay, these kind of voids are present between the particles of the bulk powder. Okay, or the bulk of the powder. Okay, this kind of thing. Okay, see, here is one particle, here is one particle, here is one, here is one. Okay, and in between these all particles there is a void space. Okay, there is a void space, there is a void space here. Okay, so these kind of voids are called as interparticulate voids. Okay, what we have seen. Okay, there are three types of voids, or this is the mass relationship between the volume and mass. Okay, see, there are three types of void. Okay, sorry first is open interparticulate void. Okay, in which the particle are in contact with the environment. Okay, particle of the powders are in contact with the environment. Okay, these kind of voids are present at the surface. Okay, surface of the uh, what we can say, the bulk material. Okay, then second one is the closed interparticulate voids. These are present inside the single particle or singular particle. Okay, these are the holes, or the system is present inside the single particle. And third one is interparticulate void. Okay, these are present in between the two, or what we can say, the n numbers of particles. Okay, this void is surrounded by the particles. Okay, means these voids, there is interaction between these voids and the solid material. Okay, next is, okay, so now we'll see the interceptions of the powder volume. Okay, which are, first is the true volume, second is the granular volume, third is the bulk volume, fourth is the relative volume. These are the types of what we can say, the types of volume. See, here we have seen the types of volume. Okay, which are considered for the powdered mass. Okay, first is the true volume, granular volume, and bulk volume. Okay, we're gonna see them here. Okay, the first one is the true volume of the powder. The true volume is the total volume of the solute particles. Okay, let me clear one thing. The true volume means the total volume of the solid particles or the powder material. Okay, solid particles in the powder material. Okay, it is a volume of a of a particles excluding the inter and intraparticular space in the powder. Okay, true volumes means this is the material. Sorry, volume of the powder excluding, okay, removing the inter or intraparticulate space in the powder. Okay, we have seen the inter or inter and intraparticular space. Here in the previous slide, inter and intraparticular space. Okay, this is inter, inside, and intra. Okay, so uh, this is the true volume, is the total volume of the solid particle. Okay, or what we can say, the volume of the powder itself, only the volume of powder. Okay, true volume means the volume of powder, total powder, or the what we can say, the only powder itself. Okay, then the next one is the granular volume of the powder. Okay, what is granular volume of the powder? The cumulative volume occupied by the particles. Increasing volume occupied by the particle, including all the intraparticulate voids. Okay, only intraparticulate voids, not interparticulate voids. Okay, or it is the volume of the powder itself and the volume of the intraparticulate spaces. Okay, what is granular volume? It is the volume of powder itself and the volume of the interparticulate space. Means interparticulate space means the volume. This, what is granular volume? This is means this volume of this all powder with, along with this interparticulate space, not intraparticular space, this intraparticular one, this intraparticular part, which means inside the particles, inside the particles, and inter means in between the particles. Intra means inside, and inter means in between. Okay, so what is granular volume? This is the volume of all this powder along with this kind, this thing, this intraparticular void, this one, this one, this one, this one, this is all the intraparticulate void. Okay, so I hope you are getting what I'm saying. The next one is the bulk volume of the powder. It is the total volume occupied by the entire powder mass under the particular packing achieved during the measurement. Okay, means the bulk volume is defined as the entire powder mass under the particular packing achieved during the measurement. Means total mass of the powder along with the packing material. Okay, this is the bulk volume. Volume of total bulk we have calculated or measured. Okay, it comprises of volume to true volume and intraparticulate volume. Means, okay, what is this bulk? What we can say, this bulk volume? Okay, it is, okay, it is the mass or the bulk or volume of this total powder. Okay, this total powder along with this open interparticulate space, closed interparticulate space, and interparticulate space, and this both open and closed intraparticulate space. Okay, volume means this total volume. Okay, this total volume of the powder is called as the bulk volume. Okay, is called as the bulk volume. Okay, it is measured along with the inter and intraparticulate void. Okay, the next is relative volume. Okay, this is the volume of material, or what we can say, the powder sample under the specific experimental conditions. Okay, whenever we perform the specific experimental condition, under that condition we used to measure the volumes. Okay, so that is the relative volume. It is the ratio of the volume v of the sample under the specific experimental conditions to the volume, true volume. Okay, means it is the ratio of measured sample or volume of sample v from taken from the true volume Vt. Okay, under the specific experimental condition. Okay, so relative volume is defined as, or we can say the formula of relative volume is V by Vt. So here V is the volume V of sample. Okay, V is the volume of sample. Okay, under the specific experimental condition, and Vt is the true volume of the sample. Okay, sample or powder. VR tends to become unity as all the air is eliminated from the mass during the compression process. Okay, so this sample we are using, okay, in this there is no trace of air, or what we can say the void. Okay, void. So this is that VR tends to become the unity as all air is eliminated, means there is no trace of void or any kind of air in the sample we are going to analyze, or which is going under the specific experimental conditions. Next one is density. We all know that density is the mass ratio of mass to the volume. Okay, can also known be denoted as d or rho. Okay, rho. Okay, in density there are three type of another volumes. Okay, just like sorry, three type of density. Just like volume, we have seen true volume, true density. Okay, we have seen granular volume. Here is the granular density. We have seen the bulk volume. Here we can see the bulk density. Okay, in this first true density, rho t. Okay, rho, this thing is also known as rho density. We can also denote it as d. Okay, so mass of the powder upon the true volume of the powder. True density is what? We know the formula of density is mass upon volume. Okay. Similarly, the formula or the definition of the true density is it is the ratio of mass of the powder upon true volume of the powder. Okay, so you know the true volume. What is true volume? We have seen true volume. Okay, we have seen true volume here. What is true volume? It is the volume of powder itself. Okay, so mass of the powder, total mass of the powder upon the only volume of the powder. What is true volume? Okay, it is the volume of powder itself. Okay, so true density can also be denoted as, or can or the formula of true density is rho t is equal to m by vt. Here m denotes or lies for the mass of the powder, and vt is for the true volume. Okay, next one is the granular density. Okay, rho g, the mass of the powder upon granular volume of the powder. Okay, granular volume can be or can be defined as the ratio of mass of the powder upon granular volume of the powder. Okay, so we can say that the formula of granular density is rho g is equal to m upon vg. Okay, means the granular density is the mass of the powder, total mass of the powder upon the granule volume of the powder, granular volume or granule volume of the powder. Okay, in granule volume we can say that there is a, see, granule volume. What is granule volume? Volume of the powder itself and volume of the interparticulate space. Okay, interparticulate space, this kind of thing, interparticulate space. Okay, so next is the bulk density. It is the ratio of total mass of the powder to the volume of the powder. What is bulk? Sorry, what is bulk density? It is the ratio of total mass of the powder to the bulk volume of the powder. total mass of the powder, and total bulk means whatever thing, whatever kind of powder you have, which kind of void it may contain with the packing material, with or without packing material. Okay, so if it is containing interparticulate space, intraparticulate space, open interparticulate space, open interparticulate space, what kind of thing or what kind of void, whichever kind of void it containing, whichever kind of void it is containing, along with all that thing. Okay, that is bulk volume. Okay, so it is the ratio of total mass of the powder along with the total volume of the powder, or bulk volume of the powder. Okay, it is measured by pouring the weight powder into the measuring cylinder, and then volume is noted. Okay, this is experimental kind of thing. We'll see this in experiment or practical. Okay, so it is expressed in gram per ml. Okay, why gram per ml? Because we are using measuring cylinder to weigh it, weigh the powder, or to obtain the bulk density of the powder. Okay, then the formula for the bulk density. Okay, formula for the bulk density is rho b is equal to m upon vb. Okay, where m lies for the total mass of powder and vb lies for the bulk volume of the powder. Okay, so we'll see the next one. Okay, next property is porosity. Okay, let me clear you one thing first. Porosity means the porous nature of the powder. Okay, the space between the particles in the powder are known to be void. We have seen the voids, different three types of voids. Okay, the volume occupied by such void is known as the void volume. Okay, void volume. This is void volume. The volume occupied by the voids in the particle or in the matter or in the powder material is known as the void volume. We have seen that. Okay, means this is the void volume. Okay, this is the one kind of mass or one kind of volume which is occurred by the or occupied by the air or the void. Okay, so this is what we can say, it is the void volume. This is the void volume. Okay, this is the void volume. This is void volume. Okay, this thing is all over. This thing is void volume. Okay, then it can be denoted as a formula for the void volume is bulk volume minus true volume. Bulk means bulk volume. What is bulk volume? It is the all over things or all over the mass of the powder along with the powder particles and the voids present inside it, packing material or packing. Voids present inside it means it is along with the powder. It is the volume of powder, interparticulate space and interparticulate space. This is totally, this is we can say, this is we can say bulk volume. Okay, and from this we can remove the true volume. Okay, we can remove the true volume. What is true volume? True volume is only the mass of powder or mass of powder itself, volume of powder itself. Okay, so this thing is just like we can find out the void volume by removing the subtracting the total or the bulk volume. Okay, from bulk volume we can remove the volume of the true volume, value of the true volume, and we can get the value about what kind of void volume the powder or whatever material is containing. Okay, next, sorry. The porosity of the powder is defined as a ratio of void volume to the bulk volume. Okay, what is porosity? It is the ratio of void volume. Okay, to the bulk volume means this is the ratio of void volume. Okay, whatever voids present inside the particle. Okay, to the bulk volume, total volume of the powder. Okay, or what we can say, the ratio of total volume of the voids to the bulk volume of the material. Means whatever kind of voids present in the specific material are value for that specific void, or the void present in that material is is the ratio is okay, the void volume is the ratio of, okay, sorry. So porosity is ratio of void volume, whatever voids present in the inside that specific particle or the powder material, okay, to the bulk volume of the material. Okay, so porosity can be defined as, or so sorry, porosity, the formula of porosity is, okay, void volume upon bulk volume, where void volume is denoted as VV, okay, capital V and small v, and bulk volume is denoted as VB. Okay, so here is that expression is given how we can find out the porosity of the specific material. Okay, this is the final formula for the porosity. Okay, this formula can be used to obtain the porosity of material, where you have to put the value of true volume and bulk volume. Okay, the formula is E is equal to 1 minus Vt upon Vb into 100. Okay, the relation between the porosity and compaction is important because the porosity determines the rate of disintegration, dissolution, and drug absorption. Okay, the porosity of the specific powder material or sample, or what we can say the drug material or whatever thing, is important for compression. Okay, for formulating the tablet, formulating the whichever form kind of dosage form we want to prepare. Okay, for this thing means, so this is applied to the solid dosage form, porosity of powder, solid dosage form. Okay, just like tablet, capsules. Okay, so in this case, the porosity is important because the dissolution properties of the powder, drug absorption of the powder, and the disintegration rate of the powder depends on the porosity. Higher the porosity, the drug absorption will be higher. Okay, because it will help the to absorb the drugs fastly. Okay, it will helps to dissolve the drug fastly. It will disintegrate in the acidic pH or the in the gastrointestinal mucosa, or what we can say the gastrointestinal environment quickly. Okay, so this porosity helps the drug to disintegrate, dissolve, and absorb fastly into the human body. Okay, so next one, flow properties. Okay, flow properties. These are, let me clear one thing. These are helpful and also important for formulating a tablet. Okay, for formulating tablet or any kind of dosage form, whatever powder dosage form or what we can say the solid dosage form. Okay, to get uniformity of weight of the tablet, the powder should possess a good flow properties. Flow properties of the powder depends on particle size, particle shape, porosity, density, moisture of the particle. Okay, these all are the important properties of the particle. Okay, these all defines the nature of particle, that how the formulation will be formed, or how the nature of formulation will be, and also the thing that how the the quality of the formulation also depends on these things. Okay, if we prepare tablets and it does not having any porosity or a porous nature, or what we can say the powder is not porous. Okay, it will affect on the solubility or the dissolution or disintegration property, absorption properties of the tablet. Okay, So the particle size also affect if we have we have to prepare a formulation and the particles are the particles of the powders are large in size. So it will affect the absorption, or what we can say, the disintegration, solubilization of the powder in the pH or gastric mucosa, what we can say that. Okay, so these things affect the flow properties of the powder. Okay, then first one is particle size. The rate of flow of powder is directly proportional to the diameter diameter to the particles. Okay, the rate of flow of powder is directly proportional to diameter of powder. Means whatever diameter is, it is directly whatever of diameter of the particles is, it is directly proportional to the particles powder's flow rate. Okay, larger the surface area, larger the larger the diameter of particle, higher will be the flow rate. Smaller the particle, small will less will be the flow rate. Okay, beyond particular point, flow properties decrease as the particle size increases. Sorry, partic Beyond particular point, flow properties decreases as the particle size increases. Means as the particle size increases, okay, particle size increases, flow property decreases. Okay, if you have larger powder with the larger particle size, it will affect the flow property. Okay, okay, it will affect the property because the surface area will increase. Okay, surface area will increase, it may get stuck into the system. Okay, and if you have powder with the smaller size, okay, if you have the powder with the smaller size, then it will increase the flow rate. It will increase the flow rate. Okay, so in these powders, the van der Waals forces, electrostatic forces, surface tension forces causes cohesion of the particle, resulting in poor flow. Okay, so these are the forces which can affect the flow rate or flow property of the powder. If this thing act on the powders, okay, or the particles of the powder, it will cause the cohesion, it will form the larger particle size, or it will form the larger particles with the help of cohesion, and it will affect the flow property of powder. As the particle size increases, influence of gravitational force on the diameter increases. Okay, influence on the force on the diameter of the flow property increases. Means if the particle size increases, suppose I have smaller particles or powder with the smaller particle size, and on that the electrostatic force, surface tension, or van der Waals forces are acting. Okay, simultaneously it will increase the it will decrease the flow rate, or it will result in the formation of cohesion. Okay, due to that cohesion, the influence of gravitational force will be increased on the particle. Okay, if I have that larger particles, the force or gravitational force, what we can say, gravitational force act on that particle. Okay, so it will affect the flow property. Okay, diameter, if the diameter is larger, okay, it will affect on the flow property. But appropriate blends of fines and coarse improves the flow characteristic, as the fines are get absorbed and coarse particle reduce friction. Okay, but if we combine the mixture, or we have the mixture of the coarse and fine particles, means larger particles with the larger surface area and smaller surface area, if we combine them, okay, that will help in in improving the characteristics or flow of characteristics, improve the characteristics flow. Okay, so if we combine both of them, okay, it will help in get it will help the fine particles, coarse particle will help to reduce the friction of the system, and fine particle will get absorbed fastly. Okay, so means if we have coarse particle, okay, system of coarse particle or powder with the coarse size, okay, larger size, it will the absorption of particles, it will affect on the flow property of particles. Okay, okay, and it will affect the flow property of particle, and gravitational force will act on it. Okay, but if we combine the mixture of fine particles and coarse particles, so it will reduce the friction, as well as it will help the particles to get absorbed fastly. Okay, next one, particle shape and sorry, particle shape. Okay, there are different kind of shape of particles: spherical, smooth particles in spherical. First, spherical smooth particles improve the flow properties. Surface roughness leads to poor flow due to the friction and cohesiveness. Flat and elongated particle tends to pack loosely, obstructing the flow. Means the spherical shape of the particle, okay, will improve the flow properties. Okay, this kind of particle will flow through the system easily. Okay, rather than the particle which are having flat and elongated surface. Okay, flat and elongated particles. Okay, rather than flat and elongated particles which packs loosely in the system after the application of mechanical force, and will affect on flowability of the particles. The next one is the density and porosity. Particles having high density and low internal porosity tends to possess good flow property. If the density of particle is high, okay, density of the particle is high, it will affect or it will increase the flow property, it will increase the flow property. And if there is a less porous nature of the particle or low internal porosity, okay, of the particles, or specific powder material, then it will increase the good flow property, or will show the good flow property. Okay, means the density and porosity also affect on the porous nature of particle, or what we can say the flow properties of particle. The next one is moisture. The higher moisture, the higher moisture content, the higher the moisture content, the flow property will be poor owing to the cohesion and adhesion. Means if there is a there is a moisture present in the particles or the particle material or the powder material, then it will result in formation of cohesion and adhesion. Okay, it will, and this cohesion and adhesion will affect on the flow property of the particles. Okay, it will affect on the flow property of the particle. So next one is angle of repose. Okay, it is the practical thing we used to perform while checking the flow properties of the particle. The flow characteristics are measured by the angle of repose. Angle of repose is defined as a maximum angle possible between the surface of the pile and powder. Okay, it is the angle between the surface of pile surface of pile and horizontal plane, just like this. Okay, let me show you. Okay, see, this is angle between this surface, this is the surface of the pile. Okay, this is the surface of the surface of the pile, sorry, this is the horizontal plane. Okay, this is the angle between this horizontal plane and this surface of the pile. Okay, this angle is known as the theta. Okay, so what is angle of repose? We used to perform this thing for calculating the flow property or good flowability of the particle through the system. Okay, so this there's an expression given for this, or the formula for this angle of repose is tan theta is equal to h upon r, where theta lies for tan inverse h upon r. Okay, tan inverse h upon r. Okay, where h is equal to height of pile, r for radius of the pile, theta is for the angle of repose. Okay, the angle of repose is calculated by the measuring the height and radius of the heap of the powder form. This is heap, pile or heap, what we can say, or this total mass is called as heap. Okay, this total structure is called as heap. Okay, the frictional forces in the loose powder can be measured by angle of repose, and the lower angle of repose better will be the flowable property. Okay, means the frictional forces or what the flowability of the powder can be calculated with the help of this angle of repose. And if the angle of repose is less, then better flow property will be. Okay, angle of repose is less, then property will be larger. Okay, because it will flow through the system, or what we can say, funnel through funnel fastly. Okay, so this will help to calculate or help to determine whether the flow properties of the particle are good enough to formulate the formulation or dosage form, or we have to increase the flowability of the powder, or add something which can increase the flowability of the powder. Okay, so these are the values. Okay, these are the values for the angle of repose which are given. If the angle, okay, if the theta is less than 25, then the flow property will be excellent. If theta lies between 25 to 30 degree, flow property will be good. If theta lies in between 30 to 40, okay, the powder can be only passable. Okay, but if the theta lies more than 40, okay, value of theta is more than 40, then the flow property of the powder can be said very poor. Okay, so to get good flow property or to get good flowable powder, the theta always should be in between the range of 25. Okay, 0 to 25. Okay, so or the value of theta should be less than 25. Okay, so next one is cars consolidation. Okay, or compressibility index. Okay, so next one is cars consolidation compressibility index. Okay, it indicates the powder's flow properties. It is expressed in a percentage. Okay, consolidation index, the formula for it, this is the density minus pore density upon tap density. Tap density means uh, the the tapping perform on the specific material into the container. Okay, or measuring cylinder, what we can say, that measuring cylinder. Okay, we used to perform this thing by pouring the volume of powder uh, into the measuring cylinder, and we used to tap it for 100 times. Okay, 100 times, and then after tapping we'll calculate the volume. Okay, after tapping we will calculate the volume. Okay, and we'll determine the consolidation index by tap density minus pore density. Means after tapping what kind of density or what amount of powder you are getting, minus the pore total poured powder into the container, into the measuring cylinder before tapping. Okay, upon the tap density. Again, tap density, you know what is tap density. Tap density is the volume. Density is the volume obtained after tapping of the powder. Okay, so therefore it is also it can be also shown as the dt minus db upon dt upon into 100. Okay, where dt is tap density of the powder and db is the pore density of the powder. Okay, determination of tap density and pore density. It is determined by passing a fixed quantity of powder into measuring cylinder. What I have told you that what it is, I told you previously that we used to take a measuring cylinder in which we poured the powder, and we used to tap it 100 times. Okay, same thing we are gonna do. Okay, and we'll notice the volume after tapping whatever powder. Suppose I have 10 gram of powder. Okay, 10 gram of fine powder, and I'll pour it into the measuring cylinder. Okay, I'll perform tapping on it, and after tapping, if the 10 gram of powder gets converted into the 8 gram of powder. Okay, that is the 8, that 8 gram will be the tap density. Okay, after tapping, what I have get, I have 10 gram of powder, and after tapping, I have get the 8 gram of powder. Okay, means the pores or the porosity can be or the air entrapped in the powder removed. Okay, okay, and because of that, I have get 8 gram of powder after that thing or after tapping. Okay, so this 8 minus pore density, what kind of or how much amount of density I have poured into the measuring cylinder, that is 10 gram. Okay, upon the tap density means 8. Okay, so 8 minus 10. Okay, let it be. So this thing will be this kind of thing will be performed for the cars consolidation index or to determine the tapped and pore density. Okay, okay, so this kind of thing we can perform for obtaining this cars consolidation index or compressibility index. So I hope you understand this thing. And the next one is the cast consolidation index. Okay, the limits or ranges for the cast consolidation index. Okay, if the cast consolidation index lies in the range of 5 to 15, then powder will be excellent. Okay, if the cast consolidation index lies in between 12 to 18, the type of powder will be good. Okay, the cast consolidation index lies in between 18 to 21. Fair, the powder will be fair to passable. Only it can pass the system. Okay, then next one 23 to 35. Okay, this kind of powder or the powder having 23 to 35 cars index will be poor. Okay, the next one is 33 to 38. This kind of powder will be having a very poor nature, very poor flowability, and powder with more than 40. Powder with the cars index more than 40, having very poor nature. Okay, so I hope you understand all these things. You have understand all these things, and we'll see we'll see the remaining topic, that is next topic is compression properties in the next lecture. Okay, so I end my lecture here at this point, and I hope you understand all these things. If okay, so this was the starting of our fourth unit. Okay, that is compression and compaction, and we'll see the next topic in the next lecture. Okay, so I end my lecture here.